We present Comfis, a system for the comparative visual analysis of medical flow data. These include comparative views of different scalar fields defined on the surface mesh, comparative depictions of the underlying volume data, and comparisons of clustered flow patterns inside the volume. In consultation with different domain experts, we derived 9 comparative tasks that Comfis should support. The first task is the retrieve value task to get the concrete scalar values at a specific position. For this purpose, the user can define a circular region of individual size and arbitrary position by clicking on one of the 3 components. Highlight individual parts on the surface mesh. A range can be set. Regions that are inside the range will be color-coded with the color map and other regions will be colored in blue. The user has the possibility to automatically find regions on one of the components where extreme values occur. For this purpose, the size of the neighborhood must be specified. Then the component is analyzed and all maxima found are displayed in a table. The user can select an extreme and the camera moves to the corresponding position in 3D. The identification of correlations between scalar fields can be performed with the correlation task. Here the correlation matrix shows the coding of the Pearson's correlation coefficient. After clustering of the path lines, the user can select individual clusters from the drop-down menu. This results in showing the path lines in the 3D scene as well as the distribution of the scalar values in the scatter plot. After determining the U-parametrization, we can compare neighbored regions with individual scalar fields. Here, we set different scalar fields of the surface mesh, the path lines and the volume. Landmarks allow the user to save interesting regions. For this, a circle can be placed around a region with an individual color. Color coding of the circle landmarks may be of interest to encode the regions, for example to highlight dangerous regions. After setting the landmark, a text can be entered explaining why a landmark was placed. Individual landmarks can also be loaded, then the camera is placed at the position where the landmark was set. It may happen that the predefined tasks are not enough for the expert using the tool. To set individual tasks, we use the Lua script. The user can program individual functions with predefined variables. This predefined function searches for the vertex with the highest pressure value. A click on show point leads to a camera animation aiming at this vertex. Thank you for watching.